Hello viewers, in this video I will discuss on the topic how to deduce the relation among the physical quantities. So we have many physical quantities, we have many formulas, we have come across many formulas. So that formulas are created or many relation among physical quantities can be created by the method of dimensions. Okay, so let us see what are the method of dimensions now. So I will explain the concept with an example. For example, I will take the time period of a simple pendulum. First, I am going to take time period of a simple pendulum. So, this time period, I am taking it as an dependent variable. So, this time period, I am taking some independent variables. Okay. So, this time period depends on variables like length of the pendulum, acceleration due to gravity, and also the mass of the bob of the pendulum. So now I am taking this dependent variable depends on these three independent variables. Okay, so I am putting it as directly proportional. So my work is to, or my aim is to find the relationship between these terms and the time period. Okay, how to find? So to remove this proportionality, I am introducing a constant which is called as a dimensionless constant K. So L, G and M. So to find the relationship of these terms with time period, I am going to introduce exponent powers to these three terms. I am introducing a power of x here, y to the g and z to the m. Next, I have to find these values of x, y, z. I have to find the values of x, y, z. If I substitute the values of x, y, z in these terms, that is it. You can find the relationship of the time period with these terms. So how to do it? Next step, I have to apply dimension. Apply dimension on both sides. Apply dimensions on both sides. So what is the dimension of t here? It is only t. So in LHS, we have to represent the dimensions of these three terms, that is m, l and t. Okay, so I have only t here. How to write the m and l? Okay, I can write it as m power 0 and l power 0 because anything to the power 0 is 1. Okay, so I can write the value of m and l in this format. Okay, so I will tell the reason after some time. Okay, so in the right hand side I am having for the constant, you know that we don't have any number or something, so we leave it. So for the length, the dimension is L. So right hand side, just write what are the terms available. Okay. So the dimension of L is capital L to the power x. Okay. So for the G, you know that acceleration due to gravity is LT power minus 2 to the power y. Okay. So for the M, you can write capital M to Z. Okay. So this is the way of representing with the dimensions. Okay, so the next step is to equate each terms, equate the powers of each terms, because I'm having here three terms m, l and t. I have to equate the powers of m, l and t separately. So first step, I'm equate the powers of m on both sides. The powers of m on both sides. So what is the power of m on the LHS? We have 0. Here if I have, see whether I am having m here? No. Here? No. I am having m only here. So what is the power of m here? It is z. Enough. So 0 is equal to z is the equation that we have got. Okay. Next I am going to equate the powers of L. Similarly, equate powers of L on both sides. See, what is the power of L on LHS? We are having 0. So what is the power of L on the RHS? See, in the first equation I am having L, the power of L is x plus. So in second equation also I am having the value of L, the power of L is y. That's it. In the third equation I don't have any L. So this is the equation. 0 is equal to x plus y. So next the remaining one is I have to equate the powers of t on both sides. So what is the power of t and LHS? It is 1. See, this is 1. So 1 is equal to, see whether I have t here? No. I have t only here. What is the power of t here? Minus 2 and y. So it is minus 2y. So from this equation, y is equal to minus 1 by 2. So from this, the value of y is minus 1 by 2. Substitute this value of y is equal to minus 1 by 2 in this above equation. So 0 will be equal to x minus 1 by 2. So from this equation, x is equal to plus 1 by 2. So from this, x is equal to plus 1 by 2. So already I have got the value of z as 0, z as 0. So I have found the values of x, y and z. Substitute the values of these three, the values of x, y and z in the first equation. Okay, so I am going to substitute the values of x, y, z in this equation. So t will be equal to this constant k into L power 1 by 2, g power minus 1 by 2 and m power 0. This is the equations. So m power 0 is nothing but 1. So I will continue here. So I can write t is equal to k L power 1 by 2. I am bringing g to downward to the denominator. So g power 1 by 2. So this can be written as t is equal to k root of L by g. Next, finally, I am going to substitute the value for this constant as 2 pi. 2 pi square root of L by g. So this is the formula for time period of a simple pendulum that we are using for many occasions. Okay, so this is the way of finding the relationship among the physical quantities. So while problem solving, they will give the dependent variable and the independent variables. You have to follow this methodology. So you know the dimensions of the each quantities, and you know to the independent variables you have to raise some to the power. So you have to find the values of the power and substitute on the independent variables. So you can easily find the relationship among the dependent variable and the independent variables. Okay, thank you.